Now, some important warnings relating to the concept of power, and these warnings are related to some of those controversies and misconceptions that I mentioned earlier. And now, first of all, the power calculations are performed before the study. Remember, this is something that we do in order to figure out if, in fact, it is worthwhile to even start the study. In fact, quite often they're used to determine the sample size. Remember, sample size is one of the factors we have at our disposal to increase or decrease the power of a test. And of course, we want to decide that before we go and collect the data, right? So power calculations should always be done before the study is even started, while it's in the planning stages, not after the study is all done. Which means that power calculations provide us with some educated guesses based on previous information. Now, why is it a guess? Well, first of all, we're guessing that there is a difference. We're guessing how large the difference is, okay? And we're guessing all this based on previous information. Right? So that creates a little bit of a problem, because if such information is incorrect, or even worse, is absent, then what can happen? Well, then what we're getting is not really educated guesses, but pure guesses, and quite often they can be wrong. Okay, so asking for the power of a test without knowing any information at all, any piece of statistics or data or any kind of quantitative information coming from previous studies can be very, very dangerous. Okay, and so what happens also is that the planned sample size may be inappropriate. Maybe inappropriate because it may be too small, or maybe inappropriate because it may end up being too big. Either way, it's going to be inappropriate. So requiring, for instance, you may have heard that in order to make a proposal for a study, many organizations request that you provide information about the power of the test that you're going to use. This is a very wise decision. They don't want you to waste your time one way or the other. But keep in mind that this can only be done if we do have, in fact, some information. When no information is available, then the best thing to do is to conduct a small, feasible, affordable study just to collect that information, and then use that information to do power calculations and then decide on the sample size. So, having said that too little power and too much power are both a problem, what are the values that we should be looking for? Well, just like we did for the significance level alpha, the value that we are aiming for is an arbitrary number. There is no scientific mathematical way of saying, well, the power should be this much or that much. But common practice, tradition, and evidence coming from research suggests that 80% usually is what people aim for. So 80% is a number you're going to see fairly often reported in research studies. If they say that their power was 80%, well, that's normal and it's okay. It's not a problem. And basically you're saying you have an 80% probability of finding the difference you're looking for, if that difference actually exists. Sometimes you're going to find power values between 80 and 95%. Well, that is good. But if you start going beyond 95%, again, it may be dangerously high. Now remember that these numbers are not scientific numbers, they're rules of thumb. Okay, we're looking at it and we're saying, that looks good. However, don't rely on them as absolute truths, and don't be surprised if other people have different ideas about what these power values should be. Okay, but certainly everybody should be in agreement that too little power is a bad thing, too high power is a bad thing as well. Why? Once again, because too much power can detect irrelevant differences. I'm insisting on this point because this is one point that quite often people forget. And people seem to believe that the higher the power, the better it is. Well, not always. It's sort of like, would you try to kill an ant that you found in your house by slamming it repeatedly with a hammer, or maybe with an atomic bomb? You don't want to do that, right? So you want to use whatever tool is appropriate for the job. So what are some drawbacks about high power? Well, for one thing, if a test has too much power, then the study and the healthcare resources may be wasted. Remember, too much power is associated with large sample size. Whatever the sample size it is that you used, if you have too much power, that means you could have done the same test with a smaller data set. And so why waste everybody's time, resources, money, and so on and so on when you can use a smaller one? But also what can happen again is that you may end up finding some very minor effect that, because of their statistical significance, may lead to a lot of excitement, and people may get all jumping and dancing about some difference that in fact really makes no difference from the healthcare point of view. So in some situation it may be more effective to rely on whether the same study has been done several times by several people under several conditions and so on, and provides the same consistent results, rather than checking huge humongous studies, which again may end up giving us a something which is very small and not very important.